This is another self-quiz video. What I want you to do after I'm done explaining the problem is pause the video and then take a few minutes and try to work the problem yourself and then restart the video to hear the answer. Okay, so determine the delta H for this reaction. 2 ethane plus 7 O2 yields 4 CO2 plus 6 waters. Given these three reactions, each of which have their own delta H, all right? This, you'll recall, is Hess's law, which says that if we can add the reactions, we can add the delta H's because enthalpy is a state function. It doesn't matter how we get there. The path doesn't matter. So if you want a hint, I'll give you a hint, but if you think you can do it right now, go ahead and pause here. If you need the hint, let it run for just another minute. So remember, so the hint is, remember that we need to take these reactions and make them look like that, the overall reaction. So the first thing we're going to do is notice, for example, that there's water here in the given one of the given reactions, and there's waters in this one, and but notice the coefficients are different. So we have to do something to make the coefficients match. And for each of them, we're going to go through and make the coefficients match up with what's in the overall reaction, as well as that they're on the correct side. And remember that when you multiply a reaction, you have to multiply the delta H. If you flip a reaction around where reactants become products, you have to change the sign. Okay, that's the hint. Go ahead and pause now. Try to work the problem on your own. Even if you don't get very far, try to do a step or two and then restart the video. Okay, here's the solution. So what we're going to do is this first reaction. Notice there's an interesting thing here. There's O2s in two places, and there's O2 in the final. So we can't use the O2 to match up what we're going to do because we don't know where it's going to end up. So don't look at the O2s. Look at the water. Okay, there's hydrogen here, but there's none in the overall reaction, so we can't use the hydrogen. But we do have water. We have 2 waters here. We need 6. So we're going to multiply this whole thing through by 3. All right, the water is on the correct side, so that's okay. So I'm going to draw a line to separate my work from my given. So we're going to have 6 hydrogen gases plus 3 oxygen gases, and those are going to yield to 6 water gases. So the delta H here, I don't know if you can hear my dog chewing in the background. I apologize for that. He's a bit of a mess today. That's going to be 242 times 3, 726, but the sign does not change, so we're going to leave that negative, 726 kilojoules per mole. All right, so we're making progress. Now, we've got in this second one, we've got ethane here. We need the ethane, the C2H6, to be on the reactant side and have a 2. So we got to flip this and multiply the whole thing through by 2. And I like to write myself a note here that we're flipping that too. So we're going to have 2 C2H6s on the reactant side, and that's going to generate 4 solid carbon plus 6 H2 gas. And the delta H now we're going to multiply that through by 2, but we flip the sign as well. So 184 times 2 is 168, so that becomes positive 168 kilojoules per mole. Now, this last reaction here, notice we've got a CO2 here. We need to have 4 CO2s. It's on the wrong side and needs a 4. So we're going to do this whole thing times 4, and we're going to flip this guy as well. So now the products become reactants. So we've got 4 solid carbon plus 4 O2s yields 4 CO2 gas. So that multiplies the delta H through by 4 and changes the sign. So 394 times 4 is 1576, but we need to make that negative now. If you flip the reaction, you have to flip the sign. All right, now we're going to make sure these all actually add up to this overall reaction that we were trying to get to at the beginning, okay? So here we go. All right. If we add these up, we notice that, for example, the one that jumps out to me right away is, let's do this one. We've got 6 hydrogens on a reactant side and 6 on a product. If we make 6 hydrogens and we use them up right away, it's like they're never there. So we're gonna cross those out. Sometimes we say cancel out for this. It's not technically canceling unless you're thinking of these as algebra equations, which is perfectly valid. So either one is technically fine, but I like to think of it as if you produce 6 and use 6, who cares that happened? All right, so now we've got 4 carbon solids here and 4 on the other side. So again, drop those out. What we've got left is we've got 2 ethanes. So far, so good. Notice that we have 3 O2s and 4 O2s. Well, that adds up to 7 O2s. That yields, we got 4 CO2s and 6 waters. Yay, so that all added up. All right, so these reactions add up to the overall reaction we were trying to get to. Now, Hess's law says if you can add the reactions, you can add the delta H's. So now we can finally add up all of our delta H's and get the delta H for this reaction. So we're going to take negative 726 plus 168 minus 1576. That's going to give us negative 2134 kilojoules per mole. All right. And that is the process for solving a Hess's law equation. We take the equations we're given, we make them match up as closely as possible, reactants to products, coefficients as well, multiply through the reactions, that multiplies the delta H's. If we can add the reactions, we can add the delta H's.